Okay, so we are live and people will be joining us super soon. Uh, we are gonna wait for 1 minute and after that we'll start the session. Till then, hi everyone. I am Madhur from TFUG Ghaziabad, and we will be starting our day 2 of ML Maths Club, where we have our expert speaker here with us. So you can drop some of your hi hellos in the live chat. We'll be waiting for some more guys to join in, and then we'll start with the session. So I can see people have started joining. So I guess we can start with our day 2 of ML Math Club by TFUG Ghaziabad. So I hope you had a good time in day 1. We hosted the session yesterday itself. So today is the day 2 of ML Math Clubs. We will be also be organizing some more sessions in the upcoming weeks. Today we have expert speaker Jyotishko Biswas. He is a AI and Gen AI leader. We're currently working in HP Finance. He has 18 years experience in AI and ML. He has also won an AI Leader Award of 2024 and Indian Achievers Award of 2024. So our expert speaker will be talking about advanced drag-powered contract compliance application, which is used to automate contract compliance for large firms. He's an industry leader and he has a lot of experience working in ML and AI and in the industry also. So you can also drop some of your questions in your chat box. In the chat box, we will be taking the Q&A at the end of the session. For now, I'll be inviting sir on the stage to present and like, hello sir, the stage is all yours.
Thank you, Madhur. First of all, thank you for inviting me. Another thing which is important is to build a community like TFUG, maintain it, bring in speakers, bring in the audience, do the marketing, etc. Needs massive amount of effort and dedication. So we fully recognize the effort and dedication which you bring. Also love the fact that so many passionate people want to learn on a Sunday evening. And yeah, I mean, hope you people go out and have some party after this talk.
Definitely.
So, all right. So let's get started. I will start the presentation. Madhur, can you just let me know when you can see the screen?
Yeah, sure. I'll let you know. Yeah, I can see your screen. It is visible to the audience as well.
All right. Perfect. So we will, like Madhur said, we will talk about an advanced RAG methodology, which in this case is self-RAG, which we have leveraged to solve a chronic business problem for Fortune 500 firms, which is in the space of compliance of the contract. So we'll come there. Uh, However, that's the focus of the topic. I mean, that's the focus of this session. So, what I would start with is the fundamentals of large language models and RAG. The idea is so the people who are experts already in large language models and RAG, bear with me for some time. I want to take everyone along. The people who are at relatively new to large language models and RAG, I just want to give you the fundamentals of LLM and RAG in simple English terms so that you can come along. Right. Then we will come to the business problem as such. Uh, in a very candid way, we are hired. So the technologists are hired to solve business problems in firms. So it's important to understand how we can leverage technology to solve a problem, which is compliance of contracts in this case, which we are covering in this session. So we'll first understand the business problem after covering the fundamentals of LLM and RAG. The next, and we will understand it well. uh, you know it's important that we understand the problem well. Then we'll get to the data. In this case, the data is the contract itself. Again, the more the time you spend on understanding the data, the better it is. So we'll go there. We'll try to understand the data well. Then it comes to how we architected the solution, what was the methodology we followed to build the solution. So we'll spend time on the methodology. Uh, then we focus on findings, and we will dig deeper in specific areas so that we can share more information with you, uh, and some information in detail in terms of how we build this application, what factors we looked at, why we considered a specific large language model, why we considered a specific RAG. So we'll go deeper and share some, in a transparent way, share some findings. And then we'll come to the Q&A. With that, let me move ahead. So, like I said, we'll talk about the fundamentals of large language models and RAG first. So, what are large language models? They are basically neural networks. These are large neural networks. What does a language model? So, we are talking about large language model, abbreviated as LLM. LLM, I mean, the LM part is basically language model. Now, what does a language model do? When you give a sequence of words to the language model, it predicts the next word. So here, just as an example, the sequence of words is despite which has been given to the large language model, the sequence of words which are given to the large language model are despite multiple complaints, the issue remains. This sequence is what we have given to the large language model. In return, the large language model generates a word which is unresolved. That's what the large language model is doing. Now, the reason why a language model is known as large language model, because it learns for massive amounts of data, and then it's a huge neural network. That's why you hear, Gemma models. Gemma is still relatively smaller, of 2 billion parameters to somewhere, I think, 7 to 11 billion parameters. Gemini is way bigger than that. Or the models like Llama, those are running from 7 billion to 70 billion. So the parameters. So these are these large size models. Now, when we say these parameters store information within them based on the data on which it is trained. In the case of open source models, they are primarily trained on open source data, the data which is available on the web, with a little bit of proprietary data. Now, the information it learns from this data is stored in the parameters. It's important to remember that. Another reason why large language models have turned very popular is, okay, or rather, the reason why large language models have turned very popular is because they are pre-trained. So you have already trained them. So the time to develop an application using a large language model comes down significantly. So just as an example, so there was a time when I was in IBM, there were, well, close to 10 years back, that was, that's where we were building sentiment analysis models. We would spend 6 months to 12 months to build a sentiment analysis model. The same solution, we can build it within 2 months using large language models because of the fact that it's pre-trained. It has learned a lot. Okay, now just want to give you a visual understanding of neural networks. Large language models, as we said, are humongous neural networks of billions of parameters. The smallest version of a neural network is what we see here. You have inputs x1 to xn. These inputs go and get aggregated or summed. Then there is an activation function which primarily converts. Activation function is primarily converting these inputs x1 to xn, and then these are weights and biases. These weights and biases are the parameters which we just talked about, or you keep hearing, right? The JEMA model has 2 billion parameters to some 7 or 11 billion parameters. Some of the large language models have trillions of parameters and so on. Those parameters are these weights and biases. Okay, so taking the inputs, weights, and biases, you are transforming these inputs, weights, and biases to get an output. And this transformation is done by the activation function. Again, just wanted to give you a visual representation of how a neural network looks like. Okay, now we come to retrieval augmented generation. On the extreme left, this is where you are, instead of using any additional retrieval augmented generation, you are just using a large language model, abbreviated as LLM. This is how you work with ChatGPT also. You have a user who sends a prompt. You are rather a user. You and I are the user. We are sending a prompt to the large language model, which has information stored in it in their parameters, which we just talked about earlier. Based on the prompt, the large language model uses its intelligence, uses the information stored in it to create a response, which is sent back to the user. This is how the ChatGPT works as well. Now, there is, if you want to add additional information to a large language model, that's where you bring in retrieval augmented generation. Now, in that case, you have a user, you send out a prompt to the additional information which is stored in a database. Based on the prompt from the database, external information, a portion of the external information is pulled out or retrieved. This retrieved information is added to the prompt and then sent to the large language model. So, and after that, you get a response. So basically, in the prompt engineering, you only are leveraging the information which is stored in the large language model. In the case of RAG, retrieval augmented generation is abbreviated as RAG, you are using not only the information which is stored in the large language model, but also external information. Why do we need that? So just as an example, suppose you have large language model which has learned using data till 2023 only. Suppose we ask them, now we ask this large language model that who won the T20 2024 World Cup. Either it will give a wrong answer or it will not be able to answer because it doesn't have the 2024 data in it. It has only learned from data, or it has only learned from data up to 2023. It hasn't learned from 2024 data, so it can't answer that. That's where you need to bring in that additional information. So in this case, if you bring the 2024 information separately as external information and store it in the RAGs database, then the prompt will be able to answer that yes, T20 2024 World Cup was won by India, Cricket World Cup was won by India. Now let's move to self-RAG. Now, as software engineers, or even when you think about products being manufactured in the plant, there is a lot of checks, lot of tests when we are doing software engineering. Or in the case of manufacturing products, there are a lot of tests on the product itself in terms of its quality. Now, the RAG which we just talked about, which is the standard RAG, it doesn't have these quality checks, and that's what is brought in when we do self-RAG. Now, additional richness of self-RAG is it brings this checks, and over and above that, it does these checks and tests at multiple points of the pipeline. So just as example, when the user sends a prompt, it first checks, is the prompt very simple? If the prompt is very simple, like who is the Prime Minister of India today, uh, probably pretty well, that's a tricky question, but who was the first Prime Minister of India? uh, that's very simple, retrieval is not needed. So it first decides whether retrieval is needed or not, because if you do retrieval, there is a cost involved of additional compute, and sometimes retrieval. So yeah, let me stay there, and then there's another check. So what happens, there are multiple documents which are retrieved. So again, there is a check which document is more relevant, and that is the document which is used, that is the retrieved document which is used, instead of using all retrieved documents. That's another check or test which is done. After that, when the response is generated by the large language model, again there is a test to check whether the response is relevant, whether the response answers all the components or all the sub questions within the prompt. That's another check. So these are various checks and balances which enhances the capability of RAG to give more coherent, relevant, accurate answer. Let me pause here and check if there are specific questions, because I just want to make sure the
Currently, sir,
fundamentals are clear.
we are not having any questions, so I guess we can move ahead. I'll post a
Okay.
reminder that if there are any questions, so I'll remind you for that.
Okay. So now let's talk about the business problem which we want to solve. Now, in Fortune 500 firms, especially who are working in the B2B side, business to business, so a firm is selling to another firm or a firm is providing services to another firm, that's where you have thousands of contracts. Uh, Contracts both with customers and contracts with suppliers as well. In this situation, what happens? So there are some technology firms who would have contracts with suppliers, like 70,000 suppliers or 100,000 suppliers. At a point of time, you have 100,000 contracts which are active, which turns into millions of pages. Or if you think about, say, for oil and gas, there are regulators, the number of contracts they have to evaluate. So contracts of oil and gas they have to evaluate are in thousands. Making every contract is compliant is humanly impossible. Now, that's where an LLM powered application which automatically evaluates whether the supplier contract, vendor contract, or the customer contract, they are compliant or not, uh, is the only solution. Um, like I said, otherwise it's impractical to evaluate it manually. Now, what are these contracts? So the contracts are something, these are terms between two firms in terms of which product will be delivered, how many units of that product will be delivered. So just as an example, suppose there is a contract, and this is a hypothetical example. There is a contract, suppose, between Coca-Cola and HP. The contract says that HP will provide, say, 5,000 commercial laptops over a period of 3 years at such and such price, and these laptops will have such and such configuration. And if there is pre-closure of the contract, this is the amount of penalty. We will maintain data confidentiality between Coca-Cola and HP for 3 years, till 3 years after the closure of the contract. So that's the document. These are the terms and conditions. Okay, so what we will do here, we will talk about this business problem is true across industries and in different settings. We will look at it from an oil and gas regulator. Now, from an oil and gas regulator's perspective, the oil and gas regulator has to look into thousands of contracts which are maintained between sometimes the government and the oil and gas company, or between the oil and gas regulator themselves with the oil and gas company, and so on. And they have to ensure that these contracts are compliant. If these compliance contracts are not compliant, there can be major risks. So I'll just take a example. Instead of getting into a lot of details, I'll tell you the exact problem. One of the one of the data security leaks happened between an African oil and gas explorer working in Africa. This happened somewhere between 2010 to 2014. Now, the oil and gas supply, I mean, the oil and gas explorer was not supposed to provide how much of oil and gas will be extracted. However, maybe accidentally, the information leaked. Now, with the leak of the information of amount of oil and gas which would be extracted, it significantly impacted the price of oil and gas in that region. Because if you know more oil and gas will be extracted, probably the prices will fall down. So it creates not only penalties for the companies, but it can have political impact, economic impact, and so on. I wanted to spend a little bit of time on the business problem because, as I said, when we go to the firms, we would be remunerated or we would be hired to solve problems. So we should understand the problem well. The second piece is we have to understand the data well. So I'll open a contract. So that I can share more detailed, in-depth work, so that I can share some details of the work which we have done for the benefit of, benefit of you all. I will focus on two terms. Yeah, there are more than 20 terms. I'll just zero down on two terms. So I'll show this is a standard contract. Okay, I will show you those terms, specific terms. Otherwise, there are grant of licenses in this oil and gas contract. It's basically the area where they can either explore or extract oil and gas. So let me go to those specific two terms. Okay. One term which we'll focus on is data confidentiality. Now, this is a contract between European regulator, OGA, and one of the explorers working in Europe. Now, the contract says that the amount of oil extracted, the samples, the future plans, different types of records, testing results, which have been documented, that can only be shared between the regulator. I mean, that can only be shared with the regulator and the crown. Yeah, United Kingdom's crown. Nowhere else this information can go out. Okay, so that's that's the data confidentiality clause. And another clause which I want to show you is, okay. Now, licensed area, which I briefly talked about, is a area where you are, where this oil and gas company has been licensed or allowed to either extract or explore availability of oil and gas or extraction of oil and gas. Now, these are areas which can even stretch to hundreds of kilometers. Since it's big area, exact coordinates of the area needs to be documented in the contract. Otherwise, even accidentally, it is possible that extraction of oil and gas happens outside the area for which the oil and gas company has been given the license, because of the scale and size of the land. So these coordinates turn extremely essential. So this is another clause which we will look at. Now let's move further. Here, so as we said, there are various terms, which has to be covered in the contract. Some of them are legal terms, uh, which ha- I mean has to be has to be covered based on law. Some of these terms and clauses are best practices followed by the firm itself, or even best practices followed by the regulator. So the two terms which we will cover, of course, in deep is license and data confidentiality. Besides that, you have terms like production commitments, which is amount of oil which can be extracted, financial terms, at what price you can sell, how much of royalty you have to give to the government or the crown, health and safety conditions. These oil and gas firms have to maintain certain safety conditions, certain uh, health, some clinics need to be there in the oil and gas extraction site, etc. So these terms are there. Now let's come to the solution design. Now, the contract which you saw, those are scanned copies of the documents. So, those contracts are stored, of course, at a particular place. Okay, even before that, the way the solution has been built is we leveraged the closed, or basically the contracts which have ended, oil and gas contracts which have ended, those have been used to create the external information which we talked about, external information of the RAG. And the active oil and gas contracts, we are checking whether the active oil and gas contracts, whether they are compliant or not. That's how we are, that's the approach we are taking. Now, the exited oil and gas contracts which are now closed, they are stored in a particular database. Of course, these are scanned copies, so these are images. Now these images have to be converted into text, so we converted it into text. Now, we know that there is a length or context length limit in large language models, right? So we had to split these contracts. So these contracts often are running from 30 to 100 plus pages. So we had to split it into parts. That's what we have done here. Then a standard way of storing information in this external information in a database is to convert it into vector embeddings. So these split parts of the contract, they have been converted into vector embeddings, and then they are stored on a database known as vector database. As I said, the external information is stored in a database. Here we have used vector database. Vector database is primarily used for storing external data for RAG, but of course knowledge graphs uh, are also used to store information. So all the closed and exited contracts are now in this vector database. Now let's come to identifying whether the active contracts they are compliant on on different terms, or they are non-compliant. So here you have an user, a prompt is submitted, a prompt checks whether a particular clause in, say, the first part of the contract, which is probably the first page of the contract, the first split of the contract, whether a particular clause is there. So whether the license area is there in the first page of the contract. That's the prompt. Now, and I'm putting it in a simple term. There's a little bit more to it. We have put it in a question answer format. So the prompt has an instruction first, and then the question comes that whether this clause is there in the first page of the contract. But yeah, I mean, primarily this is how it is. This prompt gets converted into a vector embedding. This vector embedding then hits the same database to get additional information. Once you fetch the additional information, it goes to the model. Here we have tried different large language models. Here we currently have settled down with Llama 27B. From here, the response goes back to the end user. Now I'll tell you some insights which we got. So these license areas are known as blocks. And I will talk about this insight from the perspective that why we needed vector database in this situation. Now, as I said, these license areas are known as blocks. Now, given a large language model like Llama 2, it learns on information across industries. So block, it thinks of a block as building blocks of a software technology like Java and C++. It also thinks block as the blocks used to build a wall of a house. It also thinks about blocks as playing blocks, like Lego. So it finds it very difficult to understand what block means license area in this situation. The only way to tell, or an appropriate way to tell the large language model that, by the way, the block means license area for these oil and gas contracts, is using external information as exited contracts in the vector database. And I'll show you some outputs where we have used RAG and we have not used RAG, and you will see the difference. Are we good so far? Are there any questions? Because I want that, I mean, so that we can all come together and I can take everyone along.
We have some 2 or 3 questions, but if you want, we can take it at the end of the session, or you would like to take them now.
Are they connected to what we have discussed so far, or those are a
Yeah,
little generic?
a little bit is generic, I would say. We can take them, I guess, at the end of the session. We can
Okay,
go with the flow as of now.
then
Okay,
let's do that.
great.
Now, we tried different large language models, and of course it's a cost benefit analysis. We could have, and there are different reasons of why we selected Llama 2. Gemma 2, especially 2B, even smaller than Llama 2, was performing equally well. Having said that, it is easier to use Llama 2 for fine tuning purposes. Currently, we are yet to do fine tuning, but we wanted to keep that option open. And that's why we are currently working with, currently going with Llama 2. Otherwise, Gemma 2 is quite good. I mean, it's one of the optimal large language models for question answer. Here, all the prompts are in the form of a question. So Gemma 2 was performing well, especially 2B was equally performing as good as Llama 2 7B. And since it's 2 billion parameters, it would be cost effective as well. But we wanted to keep the option open of retraining, fine tuning in the future. Now, with that, let me go one step further. Like I said, we also used self-RAG. We tried different advanced techniques of RAG, like this adaptive RAG, which we have tried. Recently, we tried something known as rich RAG. Uh, Adaptive RAG, and then of course we tried self RAG as well. Self RAG gave us additional 5% improvement in accuracy, and we tested it multiple times, so consistently it was giving us additional improvement in accuracy, due to which we continued with self RAG. As I had told earlier, self RAG is trying to test what has been retrieved, whether it's relevant. If self RAG identifies what has been retrieved is partially relevant, it again goes and retrieves. Or self-RAG also tests right in the beginning whether the query or the prompt is complex enough for which the retrieval is needed. If it thinks it's not needed, then retrieval is not done. There are situations where you retrieve, and what has been retrieved is confuses the large language model to give a inaccurate answer. So this if you know that the prompt is simple and large language model is able to answer it appropriately, give a relevant answer, then there's no point to retrieve. So after doing these appropriate checks, there are two areas where the major area where it added benefit is that it checked whether what has been, after the model, after the model has created the response, whether the response is relevant enough and answers all the components of the prompt. If not, again, retrieval is done. That check whether the LLM response is sufficient and relevant enough for the prompt, that check was the more impactful to improve the accuracy. With that, let's move forward. Now, like I said, one of the areas where we'll go deeper is the licensed area. Licensed area is mentioned as a block in the contract. There are contracts where you have more than one block. And for each of these blocks, you have these coordinates. So you can see northwest, the exact coordinates are mentioned in the contract. Now, let me show you some results. And I had specifically kept these results for explaining our work. So this is one contract, okay? Chrysaor, if I'm pronouncing it right, that's a firm, UK-based firm, oil and gas exploration firm. Now, like I said, each prompt is checking whether in one page of the contract, which is one split, a particular clause is there. So here it is checking whether the license is there in a particular page. Now, when we didn't use the RAG, we did not get the license area. And here there were 4 license areas, actually 4 blocks. It gives very nothing specific, nothing relevant as an answer when we are not using the RAG. However, with the same prompt, with this, same standard RAG, I mean, self RAG, of course, we had further use, but this is this is more for, explaining and showing how RAG turns impactful. So this is with standard RAG when was used. When we use the RAG, standard RAG, all these license areas, the 4 license areas came up, because now the connection between what a block and that block means a license area, now it is understood by the large language model because of the external information of closed contracts being stored in the vector database. However, for a different contract with the same prompt, that whether the license area is there in a specific page, there were 3 blocks in the page. Sorry, 3 blocks in the contract. Only 2 blocks came up. It basically shows that there are, it's not that RAG has 100% accuracy. And that this is the argument for having human in the loop. Or maybe once we had used, let me keep it at that. So this is an argument that why we should heap a human in the loop, why a validation is needed, why a monitoring is needed. One is automated monitoring. At the same time, you also need, once the solution is in production, application is in production, you want a human to look at the output of the monitoring, the logs, at periodically at different points of time. That's the that's why you need the human loop. Then let's talk about data confidentiality. We know that how much of oil will be extracted, what's the plan of the firm, the different maps, the sample of oil or the sample of gas, all that information can only be shared with the regulator. The firm can only share it with the regulator or the UK Crown. Now, let's see some results. Now, this is a different oil and gas company. We have asked in this prompt, and this is a one-shot prompt where we have also given an example of what type of response we want the large language model to give. One-shot prompts, which the people who are relatively new to RAG, one-shot prompt is you give a sample in the prompt itself of what type of output you are expecting. So here we have said that all the records, plans, samples of oil and gas, that information needs to be only shared with the regulator, which is OGA, and the Crown. This is the type of answer we are looking in, say, the first page of the contract, then the second page of the contract, then the third page of the contract. So the prompt goes like that. When we have not used RAG, we just got a mention that about the documentation which is done by the company, which is like record keeping, reporting, etc. But there is no clear mention that the data can only be shared with the regulator and the Crown. But when we, for the same prompt with the same single shot prompt, when we use RAG, you get a sensible response where it is said, the terms have been changed. It's not exactly how it's mentioned in the contract. Like in the contract, if you see, it's like all records, returns, plans, maps, samples, etc. Here it's all specified data, but in the output, it's all specified data provided under this license shall not be disclosed. So the language has changed, but it basically means that all the relevant information can only be shared to the OGA and the Crown, not outside. So this is how the RAG is able to get more relevant responses from the large language model. Okay, with that, let's look at the findings. So overall, we have got 91% accuracy. We are using so another step which I am in the Excel we were looking at a a intermediate step rather. Finally, the large language model says uh, it gives out what is the relevant information for the prompt, and then it also classifies whether the term, whether the clause is fully mentioned, partially mentioned, or not mentioned in that particular page. So it's a, and that's why we have measured it with F1 score accuracy. Not really accuracy, it's basically precision and recall, the mix of it. Through that, we have, that's the metric through which we are capturing how accurate a solution is. And it's at 91% accuracy, and current literature, especially for oil and gas, I mean, current literature for oil and gas contracts have accuracy around 90% or so. So most probably we will put it as a publication, and that's why there is some information we have also I have specifically withheld. Like beyond this, we had also used knowledge graphs. That's one information which I have withheld, and there are a few other pieces. In terms of results, we are looking at, see, these are at the end of the day important contracts. The clauses are there. The challenge is that the clauses in some few cases are partially there. Like in 0.5% contracts, the license area is unclear, or data confidentiality term is incomplete for 2% contracts. But the point is that since these contracts are of hundreds of millions of dollars, or sometimes even billions of dollars, these small gaps in the contract can cost millions to the firm in the form of penalty, or it can create economic turmoil, it can create political turmoil. So, and that's the importance of uh, contract compliance application, automated contract compliance application in the oil and gas industry. And it's primarily most important for the regulators rather than the firms, because the firms will have two, three, or probably max 10 active contracts at a point of time, because probably they are working across the globe, the large ones. But it turns very critical for the regulators. Um, what else? Yeah, I mean, I am best reachable on a LinkedIn profile. Madhur, can you send this LinkedIn profile, or let me put it in the chat?
Yeah, sure.
If
I have just pre-made the message. Let me put it in the chat. So,
okay,
guys, we I have put it the feedback form for the session and ML Math Clubs in the chat, and you can just go ahead and fill the feedback form. And also, I have put in the LinkedIn handle of sir in the chat itself. You can follow him, connect with him. You can also connect with him regarding all your doubts on how you can leverage your AI skills in your current career and how you can grow there. So let me just pin the message. Okay, so the message is uh, I guess we are at the Q&A time. So we have Shikhar in our studio. So one of the attendees is in our studio. Let me add him to the stage. uh, Hello Shikhar.
Hello, we are
Yeah,
having
you are
doubts.
audible. You are audible. You can ask your doubts too, sir.
Sir, yeah, I have one doubt. What kind of data is typically required for training RAG models in contract compliance?
okay. What type of data? See, even though this is all about maths, these are we can make it very simple for us. In this case, we need additional external information, or the example which I told. Uh, I need to tell the large language model that block actually means license area. And how can I tell that? Uh, I can tell that if I add in that that database, vector database or knowledge graph, whatever we want to leverage. If we add external contracts, if we add contracts in the that vector database or knowledge graph. So, based on your business problem, you have to decide what information you have to put in the database. So if it would have been for a technology industry, we have done some work for technology industry. Having said that, that's proprietary, so but we have shielded that information. um, there, if we are doing it for the technology industry, we have to add contracts of the technology industry, because then, and if it is for specifically for servers for that matter, or routers, so we have to add contracts which are of the space of servers and routers. Then it will understand the nuances of servers and routers. Does that answer your question, or you are thinking volume of data? How much of data I should store in the in the database?
Yes, like I was thinking like how amount of data we are going to train that origin.
See, here we have not trained it. Okay.
Yeah.
Now, in the external database, if we have relevant contracts, so the contracts which we had is relevant, we were putting in 2000 contracts and it was giving us good results. We had more contracts, so we put in close to 7,000 something contracts in the RAG. Now, if we have to fine tune, okay, then it depends what model you are using. So for that example, if you are using the smallest Llama 6, Llama 7B, because fine tuning Gemma to be or basically proprietary models, there are some limitations in terms of how you can change the hyperparameters. But for the open source, say for Llama 7B, you would need at least when at least 100,000 pages. But people who extensive training also can go to much more than that. You can talk about 500 k pages as well if you have the data. And that's 7B. 70B would need much more data.
Yeah, so I understand.
So
Okay,
for this
Shikhar, I
kind of
guess.
a problem, one can also think of building a custom small language model where the amount of data needed is much lesser.
I hope Shikhar sir has answered your question.
Yes, yes, I understand.
Okay, great. So I guess we can move ahead to another question by Akash, which is like, how is
Uh-huh.
a contract different from a contract that we have learned in blockchain?
Which we talked about, right? I'm wondering, when you say contract which you have learned in blockchain, what you are referring to. But uh, these are contracts between two firms. These are business contracts between two firms.
Okay, great. Sir, another
I can
question.
check that. I mean, what I maybe you can send me this question and I can check and answer it further. Aman, okay. Hello, sir. I have one doubt. How does RAG differ from traditional machine learning models in the context of contract management? Yeah. Okay, so let me answer it this way. The I think the fundamental question is, how is large language model for contract management different from traditional ML models? Because on the RAG, large language model only, you are fitting the RAG as additional information. The main There are multiple differences, but the main benefit of the large language models is that these are pre-trained. If I would have done the same contract management solution using traditional technologies, I would have at least spent 6 months to See, you can build the model much faster, but then so as to get the robustness, so as to get the right kind of testing, recursive testing, that piece takes time. Uh, so as to build a stable standard, so as to build a stable, consistent contract management system end to end, which is an application, it would take around 6 months. But when you do using a large language model, you can actually squeeze that time to 2 months to 2.5 months. Does that answer your question? Other differences, let me call that out also. Earlier, we used to use technologies like rules, uh, then n-grams. If you these are traditional, natural language model techniques. N-grams, rules, started with rules, then it's n-grams, bag of words, topic modeling, then it came to the vector representations. Now you convert, like we said, each of the page is converted into a vector representation. The longer is the vector, more semantic knowledge is stored in the vector. Mathematical, that the text is stored as a mathematical representation, and the longer is the vector, more the dimensions, more information is stored there. And it is more effective because now you are working with vectors. You're searching the similarity between one vector and another set of vectors which are there in the vector database, and this vector is your prompt. So you are comparing this prompt vector with all the other vectors which are there in the external database, and the match which you see, closest match, that is the information you are pulling out.
I hope that answers your question, Aman. We have another question from Tanu.
How do we overcome issues related to data formats, system interoperability, workforce disruptions during integration? Yeah, this is a very good question. This is a large, LLM ops question. Uh, we need to have, uh, there needs to be certain checks so as to ensure the data formats are aligned. And this is a very important question. If the data format is not aligned between the training period and the inference period, then the response will be suboptimal. So just as an example, in the prompt, when we trained, we had given an instruction. But when we are inferencing, if the question is not there in the prompt, that instruction is not there in the prompt, question is of course there, the instruction is not there in the prompt, then the response will be suboptimal. System on operability, uh, the best is to use APIs. Um, and then it's also about how well you architect that API. Uh, if you design the API in a scalable way, uh, so that that API can work with different data formats, different tools, then system interoperability will be smoother. You don't have to build custom pieces around that API. So system operability, one key piece is building scalable APIs, which can handle different data formats, different use cases. These are proper LLM, large language model operations questions. Hopefully you got some answers. Workflow disruptions, again, it uh, it needs to be well automated, they're orchestrated. You have tools like Kubeflow. Again, I think it's if I remember correctly, it's made by provided by Google only. Vertex AI is there. They are good with orchestration. Even tools like Databricks, another ML platform, you create jobs so that the workflow disruptions do not happen. They are anyways automated. So orchestrated means what? I mean, in a job, first this component will run, its output will go in the next component. That's how the second component's output will go to the third component. The entire chain is built. So Databricks, has a good system of orchestration. Vertex AI has good systems of orchestration. Kubeflow, which is specifically made for orchestration and automation, creation of jobs. They are good. It gets converted. You can use compiler to get it into a YAML file. Workflow disruptions significantly come down when you take that approach. Any other questions? Thank you for interesting question. Okay.
So I guess we are done with the questions. We are gonna wait for 1 more minute. If you have any questions, you can drop in the chat box.
And the question which you had asked about block chain contracts and the contracts which we have talked about, I can get back. Akash Tripathi, right? Okay.
I have also dropped the LinkedIn ID of Jyotishko sir in the chat box, so you can follow and connect with him on LinkedIn. So we have one more doubt from Sarita.
Like we discussed, RAG provides that additional information. Like the example which we talk about cricket. If the large language model has learned of data only till 2000, okay, so compliance applications, contract compliance applications, specific to that you are asking, right? Again, that specific example, that block is not known as license area by the LLM. The LLM thinks about block as Java, C++, because I had tested it. There are times when it says it's Java, it's C++. So then, or it also thinks about the play, the Lego and those building blocks which kids may use. That is the information which is provided through the RAG. There are various other pieces, like these are very domain specific points, that the data can only be shared with the regulator and the crown, and that's specific for UK. Now, if for an Indian, the large language model is not going to understand that the data can only be shared with the crown, because it is the large language model. Even if it has seen some contracts, it would have seen contracts across the across the globe. There would be only one or two contracts, if at all, where it is said that the data can be only shared with the crown. So these domain specific nuances is where the RAG helps, providing more relevant, accurate, coherent, complete answers. Hopefully that's helpful. Like, yeah, if I take a different industry for healthcare, so say there are large language model based applications which are checking the scans, and then it gives feedback to the doctor. I mean, it gives an initial report to the doctors that this person's health is such and such, whether he or she has some genuine problems or not. Those, you need to have a lot of medical terms which are specific to scans, so that the large language model understands it. Now, that additional medical terms, that information about scans, health, etc., those medical terms can be provided in the RAG. So what will you do? You will create this different. So like when we do get our scans, we also get a report, right? Generally, what happens in the healthcare industry, those reports of the scan with those technical terms, whether it's positive, negative, those reports, the pictures of those reports are taken and fed into the RAG.
I hope sir has answered your question, Sarita. So I guess that is it from our side, guys. It has a little bit over the time, but it's fine, I guess. So thank you so much, sir, for joining us today on a Sunday evening, and thank you everyone to in our audience who joined us for the session. The session is live on YouTube, so basically you can share the link with your peers so that they can also watch the session. I have dropped the LinkedIn ID of sir in the comments, so they can also connect with them on LinkedIn if you had any doubts after the session. So thank you so much, sir, for joining us and talking on a great topic. Thank you so much.
Thank you for inviting me, and I also enjoyed the session. And I mean, I can see the passion people on a Sunday evening asking so many questions to learn, and at the same time share. That's perfect. Fully appreciate it. Really enjoyed it.
Thank you everyone. We are going to end the stream.
Bye, everyone.